Okay, we're going to do graphing systems of linear inequalities. So this is very similar back to what we did in Module 7 with graphing a inequality in two variables. Only difference is it's more than one. So again, the calculator is really useful here. If you're going to graph, you want to do slope-intercept form. So I'm going to skip right here. Talks about, gives you some examples. Now, I want to look here. When you graph a system, you're going to have two areas of shaded. This dark region right here is where your solutions are. Okay, what I mean by solution, again, it's any point that's in there that would work for both inequalities. So I could take this point, which is at 6, 2, plug it into either one of those inequalities, and it should make them true. Other things you got to pay attention to, remember this one is an inclusive, therefore it is a solid line right here. This one is not inclusive, so it is a dotted line. So any point that's on this line would work. Any point that is on this line, the dotted one, would not work. So that's a review of some of the things from Module 7 that we did with inequalities. So it asks you to graph. Now the good thing for number 3 is it's already in slope-intercept form. So for this one, what I want you to do is go on your calculator. We're going to do y1 for the first equation. Oops, get my pen here. So y1 is, and on your calculator, remember it looks like this, and over here we have this line, and we want to change this line until it looks like this symbol right here. Remember, it's going down and to the left. Looks kind of like this one. Then for y2, we're going to put in the other one. And again, we put in like this, but we want our symbol to kind of look like that again. I'm not very good at drawing here, so that it matches this one. So if you do that, here's what you get on your graph. Now pay attention to your scale up here. So the red one, oops, wrong end, it's -3. So -3 would be here. It's dotted line because it's not inclusive, does not have the equal sign right here. And then we shade below, y is less than, so we shade below. I take the other line, y1 equals x plus 3, or is less than or equal to x plus 3, so I start at 3. My slope is 1, so I go up 1 over 1. It's a little off right there. It's a little better. And then I draw a solid line because it is inclusive. Y is less than, so I shade below the line. So if I shade below the line, I get all this, and then it's going to overlap in this region right here. So that region right there, the blue, is where my solutions would be because it fits for both lines. In other words, this area over here under that line does not work, and then the area over here for this line would not work for both systems. The only points that would work would be ordered pairs that are in here. So it says give two ordered pairs that are and aren't solutions. So one that would be, I'll write in blue, or two that would be solutions. I could go to the point 8, -8, which would be right there. And then I could also do like, I don't know, 0 and -8, which would be right here. Points that are not solutions, so those are solutions. Ones that are not solutions would be points like 0, 0. It works for the dark line, but does not work for the red line. Or I could just pick a point that's way out there, like way up here, and say -6, +6. So what I want you to do is I want you to try number 4. Again, you can pause the video here if you need to. Make sure you change the equation for the second one in slope-intercept. Graph it on the calculator and see what you get. Okay, so if you've worked these out, I graphed this one in red and shaded above. Solved this one, got y by itself. Graphed this one in blue, shaded below. And if you see right here, this area right in here is where these two overlap. It gets darker, so I'm going to make it in black. Again, things you have to be able to do. Remember, both of these should be dotted lines because they do not have equal to. And then you could pick points that are in this area here as solutions, and then pick any points that are in here that are not solutions. So special cases that occurred. And this is kind of a special case because in this instance, when you shade, the shades go apart. So there is no overlapping area. What's that mean? That means there's no solution to this one. There is no area where the shaded parts overlap. It's just a big gap in between here and no dark area. So there's no point I can ever plug in here that will make both of those true. How does that work? Well, you can see they have the same slope, different y-intercepts, making them parallel. One shaded less, one shaded more. So they go apart from each other. Okay, so let's do this example here. Let's go and graph it. So for the top one, I'm going to do in red. You start at -2. The slope is 1, so that means I go up 1, over 1, up 1, over 1. Draw a dotted line. Y is greater than, so I shade above. Graph the second one in blue. I start at 4. My slope is 1, so I go up 1, over 1, up 1, over 1 again. Now I'm going to draw a solid line through those points. Since it is equal to, y is less than, so I shade below. So in this case, the overlap region is right in here, right between them. So it's almost the complete opposite of this original one. They overlap each other, but the dark area is between. So the solutions are all points between the parallel lines and on the what line? The one that's inclusive. Okay, so on the y is less than or equal to x plus 4 line. Why? Because it has equal to. So any points that are on the solid line you have to include as well. So again, there's some your turn, and we've looked at the two special cases. So we're just to the evaluate, which is on page 551. And on 551, you are doing numbers 1 through 25 odd.